I wanna teach you about computer arithmetic, which is Booth algorithm. Okay, Booth algorithm is simple if you know it, if you know how to do it. Okay, so now let's say the question is -3 times 7. Okay, so now you have to first change them to binary number. Okay, so like I told you before, to change it to binary number, you have to do 2, 0, 1, 2, 3, right? But just remember 1, 2, 4, 8, 16, the sequence. So 1, 2, 4, 8. Which one is the sum of 3? 2 plus 1, right? So 0, 0, 1, 1. 1, 2, 4, 8. Which is the sum of 7? 4 to 1, right? So 0, 1, 1, 1. Just like that. Ooh. Now that's the binary number of 7. And 3. So we need to change them to 2's complement. What do we do? So first we need to change them to 1's complement. What do we have to do when we want to change it from binary number to 1's complement? Just shift it. 1, 0, if 0, 1, if 0, if 1, 0. And then, done. We need to change it to 2's complement. What do we do? Just plus 1. So 0 plus 1, 1, 0, 1, 1, 1, 0, 0, 1. Now this is the 2's complement of 7 and the 3. Okay, so what are these two? These two is actually M and Q. Okay, M is multiplicand, Q is I don't know what. You just remember M and Q, and then A. We want to initialize first. A equals to 0, Q minus 1 also equals to 0. And then we have to remember 3 code, which is 0, 0, 0, 1, and 1, 0. 0, 0, 0, 1, and 1, 0. This is 0, 0, or 1, 1. Okay, if the code is 0, 0, or 1, 1, it means shift right, but just shift. If 0, 1, that means A equals to A plus M. If 1, 0, that means A equals to A minus M. How do we remember this? 0, 0, and 1, 1 is for shift. But 0, 1, 0 cannot minus 1, right? So you remember it have to be plus. But 1, 0, 1 can be minus by 0. 1 can be subtracted by 0. So it's minus. Okay, so what do we do now? We have to write our needs. What are our needs? N, A, Q minus 1, M, and action. Okay, these are the things you need to remember. N, A, Q minus 1, M, and action. Okay, so what do we write here? First, we need to know N. N is count. Count for what? Bit count. So you gotta see here, we have 4 bit. 1, which is, why is it hang? Tell me right now. Okay. 1, 2, 3, 4, right? Oh my god, my pen battery is dying. So n is 4. So I have to write with my hand. Okay, A is, I told you before, we've initialized it. A is 0. So since n, we have 4 bits, so we write 4, 0, 0, 0, 0, 0, 0. And then Q, we have Q here. Take the original one, 0, binary number, 0, 1, 1, 1, 1. So 0, 1, 1, 1. Q minus 1 also we have initialized here 0. But the Q minus 1 just put it 1 digit. And M, if the M is negative, then you you write here, you write here the 2's complement of M. But if the M is positive, you need to take the original one, 0, 0, 1, 1, and put it here. Since our question shows us that M equals to negative value, so we have to write there the 2's complement of M, which is 1, 1, 0, 1. The action is just initialize. Okay, now we have one row. We have to do this until the count of n is equals to 0. But don't worry, it's just simple if you understand it. Okay, so now what do we have to do? First, we have to look at the Q and Q minus 1. The last number of Q and Q minus 1. It is 1, 0. So I told you before, the code 1, 0 here, it means A equals to A minus M. So what do? We just put at the action A equals to A minus M. So we do lah the calculation. A equals to 0, 0, 0, 0. 0, 0, 0, 0. Now, before that, A equals to A minus M, right? Now our M is negative value, so A minus negative M. So it's actually equals to A plus M. So you can just plus A with M original here. This is M2's complement, right? But we don't want that, because we can just add the value of A with positive M. Here, 0, 0, 1, 1. So we add 0, 0, 1, 1, 1, 1, 0, 0. Now this is our new value of A. We put it here. What? 0, 0, 1, 1. And then if you've done this calculation, whether A minus M or A plus M, you got the new value, right? And then you have to just copy the above code. The M, you just let them be empty. And then after you go you do the A minus M, you got the new value. You always have to shift. Okay, every count you have to shift. Okay, so how to shift, right? You just copy this 0, then again 0, and then you do 0, 1, and then for Q 1, 0, 1, 1, 1. Okay, understand that? Just take the previous code of the above value, you put it down here. Okay, this is the Q, right? This is Q minus 1, and this is A. Okay, now after you done that, that is the count of 3. Now we look again at the Q and Q minus 1. Now it's 1, 1. So what I told you is 1, 1, shift, just shift. So you do the same. Just do the same. 0, 0, 0, 0, 1, 1, 0, 1, 1. Okay. This is 2. So now we look again at Q and Q minus 1. It's 1, 1 again. So we just do, this is 2, 1. So 0, 0, 0, 0, 0, 1, 1, 0, 1. Okay, now we look again at the Q and Q minus 1, 0, 1. So now 0, 1. So here 0, 1 is A plus M. So we do here A equals to A plus M. Okay, remember I told you that our M is negative. So A plus M equals to A plus negative M. So it's actually equals to A minus M. But we can do the A plus the 2's complement of M, which is negative. So we go, now A is 0, 0, 0, 0, 0, 0, 0, 0 plus 2's complement of M, which is 1, 1, 0, 1. We add them 1, 0, 1, 1. Okay, this is our new A. What? 1, 1, 0, 1. 1, 1, 0, 1. And then I told you if you do the calculation with the A plus M or A minus M, you have to, after you find the value of A, you have to just copy the rest. 0, 1, 1, 0, 1. Okay? And then we go to the next step. Q and Q minus 1. Oh, no. No. Remember we first have to shift them. Because anything you do, you just have to shift them after you do it. So shift them. 1, 1, 1, 0. 1, 0, 1, 1, 0. Okay, so now this is the new value, which is 0. Done. We've done because we achieved the 0 bits. So what do we have to do now? We must look. We just have to look at this A and Q. First, we have to look here, the first value, which is 1. This will determine your sign. If this value is 1, then it's negative. If this value is 0, then the answer must be positive. So this this thing, you have to change it to 2's complement and change it to decimal. So first we change it to 2's complement. We must change it to first complement first, right? So we gotta do 0, 0, 0, 1, 0, 1, 0, 0. Just shift. If 1, 0, if 0, 1. Okay, that's not too hard. And then you must plus. Don't get distracted by this lah. I go another color. Okay, this is the negative. Okay, now after you have change it to first complement, you have to change it to 2's complement, which is just plus 1. So 1 1 0 1 0 0 0. Okay, now you have to change it with decimal. This is 1, this is 4, this is 16. So add them up, equals to 21. But don't forget our sign here negative, so we have to put it here, negative 21. So how to check if our last answer is true? Just multiply it normally. Negative 3 multiplied by 7 is equal to negative 21. So that's what we got. That's all for computer arithmetic, both algorithm.